One, two, three.
What's up, team? Today we're going to solve some quadratics by factoring. We spent a whole bunch of time factoring, and you may be wondering, like, what's the point? Why do we do this? That's neat, but why? Good question. We are actually going to apply our factoring skills today as we solve some quadratics. So I have some step-by-step, but we're just going to dive into examples and refer to the steps as we go. Learning target below, I can solve quadratic by factoring. So let's do it. The first one, it says solve for x, and we're given this equation, x squared equals 5x plus 14. We learned in previous videos we can solve this by graphing if we want to. This one, we're going to solve by factoring. So, step one, gather all the terms on one side. That should feel familiar. We've done this before. So, I am going to gather everything onto the left side. The reason I'm choosing that is because the a term, the x, in this case the x squared is positive. I want to keep it positive. So, I'm going to subtract 5x from the left. From the right and the left. Gotta do it to both sides, not just one. That leaves us with x squared minus 5x equals 14. Cool, but I still want to take more things and send them over to the left, so I'll subtract 14, leaving us with x squared minus 5x minus 14 equals 0. Great. Now we have this quadratic on the left-hand side. We have stuff equals 0. Well, if you ignore the equals 0 for just a quick second, we'll just put it on hold. We're not going to throw it away. We'll bring it back shortly. We have this x squared minus 5x minus 14. This is something that we've seen before. We know how to factor or how to unfoil this business. This is the stuff where we have two sets of parentheses. We get it into FOIL form here. We know that x times x is x squared when we FOIL, so it's just x plus or minus stuff times x plus or minus things. So it looks like two numbers that multiply to negative 14 add to negative 5. I think this is going to end up being negative 7 and 2, because negative 7 times 2 is negative 14. Negative 7 plus 2 is negative 5. If that doesn't make sense to you, check out previous videos. We talked about it. Unfoiling is, I think, the title or something like that. Okay, now we have this equals 0 business going on. Now we need to solve this. Wow, this looks super complicated. But it's not. This is actually a huge, giant, magnificent shortcut for us. Because, recall, when you have some number, any number, let's just do a little work on this side right here. New example. If you have some number, it can be like 5, and you multiply that by 0, well, isn't that just 0? What if you had like 1,000,000, and you multiply that by 0? Isn't that just 0? Anything times 0 is 0. What we have here with our example is we have some number times some other number. We just don't know what the numbers are because we don't know what that x equals. So if we can force this chunk to equal 0, then we end up with 0 times stuff. I don't even care what stuff is, because if it's multiplied by 0, the whole thing is going to equal 0, making this equation true. So, well, the x value that makes this stuff equal 0, isn't that just 7? Because 7 minus 7 is 0. And then if I plug in 7 up for the other x as well, that's 9, but I really don't even care what that is, because we end up with 0 times 9, which equals 0. So one of our solutions here is x equals 7. That was pretty simple. There's a second solution though. It's the x value that makes this chunk equal 0. And I think that is going to be negative 2. So if we plug in negative 2 for x, we get negative 2 minus 7, which is negative 9. But again, I don't even care what that is, because the sweet spot here is over here. When we have negative 2 plus 2, negative 2 plus 2, that's 0. We have 0 times stuff, and that equals 0. So x equals negative 2. So when we factor this business, when we started it, it looks difficult. And then when we factor it, it still looks kind of tricky. But once you recognize, hey, if I can make one of these things, one of these sets of parentheses equal 0, then 0 times the other stuff, don't even care what the other stuff is going to equal 0, making our equation true. So factoring this makes it real simple to solve. Okay, one more example. What if you can't unfoil it? Good question. Say you're given something like this, solve for x. We have 3x squared minus 6x equals 0. For something like this, we can identify the greatest common factor. The greatest common factor in this case is 3x. So we're going to undistribute. We're going to take that 3x out and say 3x times, well, this looks like x, and then it's going to be minus 2 equals 0. Okay, this is super similar to what we had just a minute ago, except for here we had two sets of parentheses, now we have one. But really, if we wanted to, I suppose we could throw this in parentheses. That's fine. That's legal math. Now we're going to apply the same concept. What x value makes this first chunk equal 0? What x value makes the second chunk equal 0? Well, the first one, 3 times x, what makes that equal 0? That's just when x equals 0. So if we said 3 times 0, if we plug in 0 for x, times 0 minus 2, does that equal 0? Yeah, because we have 0 times stuff. In this case, it's negative 2, but 0 times negative 2, that does work. So x equals 0. That's one of our solutions. The second solution is whatever makes this set of parentheses equals 0. This one's 2. Because if we have 3 times 2 times 2 minus 2, that's just 6 minus 0. That equals 0. That checks out. So our second solution here is when x equals 2. All right, we've checked it. We verified it algebraically. If you're super not convinced, you could take these, apply what we did in the previous videos, graph it, throw it on Desmos, sorry, I misspoke there. Throw it on Desmos, and you will see that this parabola, this first one, is going to cross the x-axis at 7 and negative 2. Those are the two x values where it crosses. And the second one, it will cross the x-axis, looks like right at the origin. That's cool. And then when x equals 2. All right, this is how we apply factoring to solving quadratics. Factoring serves as a giant shortcut or cheat code, making this a whole lot easier for us. All right, let's dive into some practice problems. You got this.